Jai Hind. Our topic is introduction to some functions. So we will discuss about functions graph. So first functional graph is constant function. As its name suggests, constant function. So constant means some number. So first is constant functions. Constant function. Its graph is similar. Suppose this is first quadrant and this is x-axis, this is x-axis, and vertically is y-axis. So constant functions always give just line that is parallel to x-axis. So this is constant functions graph, and this distance is c. C means some numbers, so c is this distance. So this is the graph of constant functions. So a function is said to be constant if f of x is c. So constant functions can be written as f of x equal to c. C is some constant number, and c here is element of real number. C is element of real number. C is element of real number. Okay, so this is the constant function, and c has some values. Suppose x is element of a, and this is the constant because it is parallel to x-axis. It does not change any distance between them. So in parallel line, distance always every time it is fixed. And in this constant function, range of constant function is always is equal to c. Range of function is c, and domain of this function is real number r. R means real number. So range always gives us the value of c. C means constant number. We get the output c always, and domain is whatever we put the input, we give the input, that is called domain, and that is there is no restriction. There is no restriction for input. So domain is r and range is c for this function, constant function. Second function is we are discussing is identity function. Identity function. So identity functions graph. First we draw the quadrants, and its graph is, suppose, passing through the origin, and this straight line is the graph of identity function, and this angle is 45 degrees, suppose. So identity function for f of x, suppose we are taking x, so its graph is f of x equal to x. Graph is this line that makes angle 45 degree with x-axis. This is minus x, this is plus x, and vertically is y and minus y. So this line f of x can be written as y. Sometimes we replace f of x with y. So y equal to x graph is this one. So this line indicate y equal to x graph. And if we find the range of this and domain, we get domain and range both equal to r. R means real number. R means real number. So if I put any value on this f of x, there is no restriction. I can put, because there is f of x equal to x, I can put every real numbers in this f of x equal to x. There is no problem. Every value will satisfy. And what we get? We get y equal to x. Y equal to x means range we get y, that is every value of real number. So if I put the graph, I made a table for x and y. If I put x equal to 0, in this case y we get 0. So 0 0. If I put x equal to 1, I get y equal to 1. If I put x equal to 2, then I get y equal to 2. So this type of table I can generate to draw this graph. To draw this graph, I need some coordinates, and these are called coordinates: 0 0, 1 1, 2 2, 3 3. So therefore these are the points. This is 0 0 origin. Now 1 1, suppose x1 and y1. Similarly 2, x2 and y2, 2 2. So this type of infinite points we can generate. To draw the graph we need minimum 2 points, maximum we can take 4, 5, any more than 2. Next one is modulus function. Modulus function graph is always lies in first and second quadrant. Suppose this is graph of modulus function. 45-degree makes line on both side. This is modulus function, and this is one vertically is y, horizontally is x. So this graph indicate modulus function, and we can represent modulus function f of x equal to these two lines are represented by modulus function. It means we get value x, we get value 0, and we get value -1. So x we get when x is greater than 0, 0 we get when x equal to 0, and x less than 0 we get -x. And what is domain and range? Domain for modulus function is R. So for every input we get, we can put every input, therefore domain is R. And what we get output, that we call range. So range is always positive, y value is always positive, so positive real number is called range. And if I put f of x equal to modulus x, if I put the table of x and y variable, I have to put x equal to 0. So if x equal to 0, f of x is 0. F of x means y equal to 0. If f of x is 1, then x is 1, then I put x equal to 1, I get f of x equal to 1 plus 1. So 1 1. Suppose I get x equal to -1. So if I put x equal to -1, I get value -1 in the modulus gives always positive sign. So +1 we get. So f of x is +1. So every value of negative convert into positive value. Suppose I put -2, I get 2. And in this way we get table, and this table makes this graph. This graph is made from this table data. Next, fourth one is, after third one, square function. Square function, this is called square function. And in this function, you see in the modulus function there is straight line, but in a square function you see parabola. This is called parabola. Y equal to x square, this is the parabola. This is the graph of square function, and its equation is f of x equal to x square. Domain is real number, we can put every number. So domain is R, R means real number, and range I get is always positive, R positive. So R positive is domain range, and same range we get in the modulus function R plus. So this is the graph, and we can make this graph by making the table. So x and y, if I put x equal to 0, I get f of x equal to 0. F of x is called y, so y get 0. If I put 1 here, I get f of x equal to 1. If I put -1 here, then I get -1 square, that is also 1. So y equal to 1. If I put 2, so I get y equal to 4. So this type of many points I can generate and draw the graph. So what is the shape of this graph? This U shape. This U shape represent x square functions. Next one is cubic function. Next is cubic function. F of x is given x cube, that is called cubic function. So cubic function, its graph is like a in first and third quadrant. First, second, third, four quadrant is there. So first and third quadrant covers by cubic function, and I get domain. Domain means I can put every number. So R is the domain, and range for this cubic function is also R. I can get the value of negative as well as positive. Now draw the graph by taking the point. So f x equal to 0, I get f of x equal to 0. X equal to 1, I get f of x equal to 1 cube, that is 1. If I put x equal to 2, I get f of x equal to 2 cube, that is 8. If I put minus 1 for x, I get minus 1 cube, that is minus 1. If I put minus 2, I get minus 8. So this way minus sign of y we get in this third quadrant, and minus x and minus y in third quadrant, and plus x and plus y we get first quadrant. So first and third quadrant it covers this graph. Next one is square root function. Here is under root sign is given, so that is called square root function. So square root function. So in this square root function, the graph is lies always in first quadrant. First quadrant. So f of x equal to under root x. So domain in this case is positive real number, because negative number we can put in the square root sign, otherwise it become not defined, imaginary or imaginary. Range for this is positive real number r plus. So domain is r plus and range is r plus. So it lies in first quadrant because range and domain both are positive in first quadrant, and we can take points on this graph. If I get x0, I get f of x equal to 0. If I take x equal to 1, I get f of x equal to 1. And similarly 4, I take f of x, so under root 4 is 2, f of x is 2. Similarly I take perfect square number 9 for x, so I get under root 9 is 3, so f of x is 3. So this graph forms. Next is 7th, f of x is minus square root x. So this is similar to previous one, only difference is domain is plus r. It means in the square root sign I can put only positive real numbers, but range is I get negative numbers due to this minus sign. So I get r minus number as range, and graph of this function is lies in the fourth quadrant this way, because range is negative, y is negative, range means y, so y is negative, x is positive, domain means x, so it will lie in the fourth quadrant. First quadrant, second, third, fourth, this is fourth one. And I can make table. If I take x0, y get 0, I get x1, y is 1. I take x equal to 4, so square root 4 is 2, and minus is there outside, so minus 2 we get. If I get 9, in square root 9 is 3, so minus outside is there, so minus 3. So this way we get the points that will draw this graph. These points are important to draw this graph.